Buick in 1966 and ultimately retired in 2005. And over the years, I had a lot of interesting assignments from everything from turbo engines, supercharged engines, but probably one of the most interesting ones was when I was part of the Special Products Engineering Group, and that's what I'm going to talk about a little bit about today. Now, remember that this is constructed from memories that are 30-some years old. So bear with me if there's some twisting of facts and maybe we look better or worse than we did, I don't know. But to set the stage for how Special Products Engineering was formed, we go back to the first fuel crisis, which actually hit in 1973. That had a profound effect on the industry, and Buick really seriously, because we were only marketing big cars and engines at the time. So when people are looking for economy cars, we didn't have much to offer. So anyway, that ended up reawakening an interest in the V6 engine. The original V6, go ahead.
My mouse is tight.
I can't happen.
I know it.
Oh, dear.
There we go. The original V6 was introduced in 1962 as a means of better competing with a low-cost and highly fuel-efficient engine. Next. Yeah, you're okay.
Yeah, but it's on.
It's on automatic.
Yeah.
Buick had been using the aluminum 215. Whoops.
Yeah, it's on automatic.
It's on automatic.
Okay.
You want to reboot? You need to take it off slideshow.
We'll just go back to last previous one.
Where is she working?
Okay. You okay now?
I hope so.
Buick had been using the aluminum 215 V8 in these cars, which was fine in the market, but in a market where these cars were marketing, cost was very important, and we were using probably one of the most expensive engines to produce in our lineup, being all aluminum. So something had to give. So the V6 was developed in record time and brought to market and was used in these models from 1962 through 1967, when big V8s and muscle cars and big cars became the norm. The tooling was then sold to Kaiser Jeep, and they used it in these models for a few years, and eventually the tooling was mothballed when American Motors bought Jeep, and then they wanted to use their own inline six in the product, so that's how the tooling ended up being mothballed. Go ahead. Then when the fuel crisis hit, Buick negotiated buyback of the tooling and reintroduced the V6 for the 1975 model year. It got great fuel mileage, but with the engine producing just over 100 horsepower, it wasn't very exciting. In 1975, Lloyd Royce was appointed Buick chief engineer. One of Lloyd's objectives was to revitalize the whole Buick lineup with more youthful and performance-oriented customers. And as part of that initiative, Herb Fischel was brought in to help create some racing contacts and to begin to develop some aftermarket contacts to create some high-performance parts and interest. This activity was called Special Products Engineering, and the group was born. Okay. Some of the initial efforts centered around creating Buick as an entity in racing, so Buick started to dabble in NASCAR. With quite a bit of success, Buick loved it, and a lot of teams flocked to run Buicks because they discovered that the Buick Regal body style was the best for aerodynamics. So we had a real parade of Buicks. Okay. Buick was even awarded the Manufacturer's Trophy. This is Bobby Allison when the award was issued. However, NASCAR officials wanted to see more Chevrolet, Ford, and Dodge battles, and this was their words. The parade of Buicks, as they put it, had to stop, so changes were made to penalize the Regal to give other brands a better chance, and we learned a hard lesson in the politics of racing. what they ended up doing, they took our air dam, which was a production piece, and lowered our rear spoiler, which was lower than what everybody else could use, so we weren't very competitive from that point on. At that point, okay, go ahead. Special Products Engineering objectives were restated to make the V6 a recognized competition power plant, focus on market opportunities for special vehicle programs, and expand show vehicle and press coverage. While the mainstream of engine engineering focused on improving the engine with major changes like the even firing order engine, and a lot of continuous improvement like the free breathing heads, a lot of new technology, and even turbocharged engines. Special Products was busy establishing a reputation for the engine in various aspects of motorsports, one of them being the street rod activities. Part of this reason for our interest in this was to appeal to the engine enthusiasts to generate some buzz about V6 engines. An individual started to install V6s in their street rods, which indicated we were making progress with the engine enthusiasts. The enthusiasts are very important because they're the go-to people of people who ask about engines and whatnot, so it was important to us. V6 was promoted in various forms of racing. Here's a Skyhawk running at Bonneville. The car actually set a class record of 167 miles an hour using production-based high-performance parts that we call Stage 1 parts. You'll hear me refer to Stage 1 and Stage 2 parts. The difference being Stage 1 parts could be machined on production equipment, but the Stage 2 parts were strictly racing stuff and would no longer go down the machining lines in the engine factory. The V6 began to attract the attention of hot rod and motorsports press, which was one of our objectives aimed at getting enthusiasts thinking and focusing on the V6, much like the Ford Flathead originally had been, and later the small block Chevy had enjoyed. Then, in 1981, Buick was again chosen to provide the pace car for the Indianapolis 500. This one was powered by a high-performance V6 engine. During the discussions about this pace car, Lloyd Royce, who was by then our general manager, asked the question, what would it take to make the V6 that could compete at the Indianapolis 500? So now, the Special Products Group objectives were changed to include competing at the Indy 500 with a V6 engine. The Indianapolis 500 had been the most watched race in the world, both in terms of live attendance and TV audience. And so the objective was to create interest and talk about the Buick name for all those millions of viewers. So this objective caused a significant amount of design and development work to be started. So we could provide engine parts that would not only withstand the loads for a full-blown race engine, but also had the power capability. We developed two-cylinder blocks, a 3/8, which was the one that had water cooling between the bores, and there was a 4/1 provided for maximum displacement capability that had Siamese bores. Ultimately, the 4/1 became what most of the race programs ended up using. Okay, the heads incorporated 6-head bolts for bore and were originally made of iron, but were later converted to aluminum for weight reduction. Eventually, aluminum cylinder block was also offered. But specific forged pistons were developed. And we also developed a specific forged connecting rod. Basically, this was a specific casting version of a Corolla rod. And later on, I'll mention a little bit of how we got here and why we got to our own specific casting. Go ahead. We had forged steel crankshafts were designed and developed. They could be machined for a variety of strokes. I think their minimum stroke was 3.07, if I'm not mistaken, for like the Indy engines, and 3.625 for the natural aspirated 4.5 liter ones. Specific valves, go ahead, were provided for the stage 2 head. They were both longer and larger to accommodate the high flow port designs. But this was a set of parts we call the rev kit, and the purpose here was to provide more spring force to the lifter itself, so that it prevents valve float at high RPM. We were used to tell racers to not race over 8,200 RPM, but that's like dangling something in front of a kid. So commonly they ran about 8,800. By the time the Indy program ended, it was running about 9,200. Of course, drag racers were running over 10,000, so they were pushing it pretty hard, especially with the big valves and whatnot. Well, yeah, go ahead. We also specified camshafts as a starting point, because most engine builders, they wouldn't take your word for it on any cam. They all had their favorite that they wanted to have ground, but we gave them a starting point that we knew would work, and then they modify from there. But this is a roller rocker setup that we specified, that was provided by one of our affiliated companies, and we specified. And this was a collage of a lot of the heavy-duty parts that we offered. Later on, we added more to it with the distributorless ignition systems and even electronic fuel injection systems and whatnot. But these were the basic hardware parts. Good. This is a catalog page of some of the parts. The purpose here was to be able to show to the race sanctioning bodies that the parts were available for purchase by anybody who wanted to buy them. Most organizations were very concerned and suspicious of manufacturing, making one-of-a-kind parts for a specific race team or whatever. So we had to show that these parts could be bought commonly and were available in order to be able to allow to compete with them. Okay. Another important activity that Special Products supported was displays and support at national events. This one happens to be at a street route event, but we also had displays and booths that we manned at SEMA and the Circle Track trade show during Daytona Speed Week. I knew that we'd achieved some level of notoriety when at Daytona, a fellow and his wife, neither one looked like they'd been to the dentist in about at least 10 years, come up to the booth and with a torn T-shirt and whatnot, and said, "How much to buy one of these V6s?" And I said, "Well, we only sell parts, but one of our engine builders, Jim Ruddles, happened to be there at the time." He said, "Well, with the parts and the build up, you're talking around $35,000. And says, "Yep, you got to have me one of those." So I begin to understand racing as a disease. So it was kind of fun. But okay, next is the V6 really had its first very successful program in drag racing. This is Larry Dora's D kind of altered car. This car ran in the low 9 seconds and just under 150 mile an hour hit. That was a very successful car and won several events with it. There are also a number of Regals that were very competitive in the series. The one on the bottom here is a very interesting story. That car got put together, and with some arm twisting from the people who owned it, and us, we arranged to have Leonard Emanuelson, who wrote for Hot Rod magazine, drive it at the maiden event. Well, this turned out not to be so good. What happened, he was told to win but not be a hero. But instead, he went and beat the index by close to 2.5 seconds. So for future events, NHRA reset the index by 2.25 seconds. So what looked like a good, surefire thing to gain publicity backfired on us. Okay, go to the next. The next one was interesting car was Buddy Ingersoll's turbo-powered V6. Originally, NHRA allowed this car to compete in Pro Stock, which usually ran the big block mountain motors. Buddy ran in the low sevens and 192 mile an hour, and he didn't win, but it scared the participants and NHRA enough about messing up the whole Pro Stock thing that they outlawed it after the first event, and then they changed class to. So all in all, go ahead. All in all, drag racing was a very successful program for us. This is all during, I believe this was '85, where you can see all the places where we either were event winners or runner-ups. So it was a very successful program. Okay, go ahead. We also, unfortunately, not a very good picture, I guess, had a lot of success in road racing, at first in the IMSA series. This was Robert Overby's Regal that ran in the Kelly American Challenge Series in 1984. He won several events with the car. They used a 4.5-liter V6 and produced about 540 horsepower, 530, 540. So anyway, to get to this displacement, the stroke was increased to 3.625 inches. This, along with the high lift cams, required the rod bolt to be shortened so that they could have clearance between the rod and the cam. Well, you remember the special connecting rod I talked about? This was a car that demonstrated the need for that. At Daytona, he crossed the finish line just as the rod bolt let go. He won the race, but couldn't even complete a victory lap. He went up in smoke at the finish line. So we went back and, of course, specified a connecting rod. And that was kind of a recurring problem with a lot of the special products engines, because while we designed and developed the heavy-duty parts, you're at the mercy of engine builders to really put the things together, and a lot of times they did stuff that was not good design practice. So then a problem like this would occur, and we'd go back and design another part and specify it. So it became kind of a vicious cycle. You'd fail something, then go fix that piece, and then go to the next piece. So overall, it improved the breed, though. Okay. For 1985, Tommy Riggins ran this car in the MC Kelly American Challenge, and he won the championship in the series in that car. Patty Moise successfully competed with the sister to Tommy, Somerset Buick. Go ahead. He and Patty actually finished 1-2 in a number of races, and she really made a name for herself in that for being one of the top-notch countrywide female racers before the Danica Patrick time. Go ahead. This was Elliott Forbes Robinson's car that went in the SCCA Trans Am series. Interesting story of how we got into having Elliott Forbes Robinson run an SCCA with this. Dennis Fisher, who was an old-time small block Chevy engine builder in California, was furnishing V8 engines to Elliott Forbes Robinson to race in SCCA. Well, he heard about the claims that the Buicks that were making over 500 horsepower, and he didn't believe us. So remember the conversation with Dennis the first time very clearly. He said, I tell you what, I'll put one of those together, and if it really makes 500 horsepower, I'll have Elliott Forbes Robinson run one in his car. Okay, that's a deal. Well, he put it together in on the very first dyno pull. He made 530 horsepower. So then we had this car running, and quite successfully. He won the Detroit race as well as a number of other races that season in SCCA Trans Am, which was kind of the first for Buick. So really kept expanding the visibility and the name for the engine. Right? On Track magazine took notice and predicted success for the Turbo V6 that a couple of teams were planning to campaign in the IMSA series. We liked the IMSA series, especially like the GTP class, because it had been dominated by Porsche and a lot of other foreign manufacturers until we came on the scene. Go ahead. This IMSA GTP car was powered by a turbo intercooled V6 run on gasoline, produced over 1,100 horsepower in racing form, so it's a pretty stout car. Go ahead. The sister car to this one was run by various drivers at specific races. At Daytona, on the road course, Emerson Fittipaldi drove it. And this one, he was leading the race by a large margin, and I was watching and feeling really good about it. Then I see the car engulfed in flames and stopped on the back straightaway. It seems they oversped the turbo and exploded the compressor wheel. And I used to keep that piece of the compressor wheel on my desk as a reminder to watch out when things look like they're really going too good to be true. Okay, next. And, that car actually competed in the 24-hour race at Le Mans, and it did pretty well. It ultimately retired after 19 hours because of a gearbox failure. That was another thing, you know, the engine, the gearboxes and everything were set up for dual overhead cam engines, and didn't have a whole lot of torque. Well, we come along with a bunch of torque, and gearboxes plagued us almost everywhere we went. Go ahead. Also in the IMSA series were what we called the Camel Light cars. These were lighter and used non-turbo engines. Most of these used Nissan six-cylinder engines before Buick became the engine of choice in the series. Go ahead. We use this series as a test bed for our racing fuel injection system because the rules would allow it. We wanted to have multiple fuel injection on many of our race engines, but especially for the turbo applications, we could not get enough injectors with enough flow rate to cover what we needed. So we were saddled with the old constant flow Hilborn type systems on the turbo applications specifically until we could get injectors that would handle it. This is where a slide that shows where Buick V6s won road races. We won in IMSA, NASCAR, Daytona, Camel Light, and Trans Am. You notice that I mentioned NASCAR. Originally, NASCAR wanted us to promote the V6 in what was then the Busch Light series. And so they gave us a couple 100-pound weight brake and a restrictor plate relief for the super speedways. And at first success was kind of spotty, but ultimately it became the engine of choice, and like in '86 it dominated the series. So very successful in that respect. Go ahead. Another interesting thing that Special Products did was help teams that ran Buick with on-site instrumentation. This could provide real-time data from a car on the track, usually during test sessions. This technology, of course, is very commonplace today, but Buick Special Products actually pioneered this back in the mid-'80s. We call the system OSCAR for On-Site Computer-Aided Research. Go ahead. The Cube Van Howsam computer geeks that were the brains behind the equipment, and dealing with them was kind of an experience all myself. But go ahead, next one. It provided, you can't tell much from the slide, but it provided real-time information on axles, and we were able to actually put an engine into an Indy car and start testing. This was being tested at the TRC track in Ohio. At that time, we were producing about 810 horsepower on methanol. By the time of the '84 race, the engine was producing about 840 horsepower with Indianapolis boost limits. At the recommendation of the series sponsor, which was PPG, Scott Brayton was enlisted to compete with the Buick V6. On the first weekend of qualifying, Scott spun out, so he had to qualify in the second weekend. And at that time, he set a track record of over 204 mile an hour, almost 205. He had straightaway speeds of 215. Go ahead. His overall, for the 4 laps, his overall average is just under 204 mile an hour. Press reports at that time were very flattering, and of course Buick was ecstatic with the preliminary reports. There were actually 2 Buicks in the race that year. One was driven by Pat Bedard. Well, Pat crashed fairly early in the race, and Scott actually dropped out about 2/3 of the way through because of with burned piston. That was a complex issue that started with oil pullover from the dry sump tank that ultimately caused detonation and then caused the piston to go. For 85, we thought we had a much better chance with Pancho Carter driving the Valvoline Special, fielded by Rick Gallus Racing. Pancho qualified on pole that year, and Scott Brayton was second. Okay, this was the year to feel the thrill of victory and the agony of defeat. This was the leaderboard atop the tower at Indianapolis during the 6 laps, because what happened, there was a crash on the first lap causing a 6-lap caution, very extended caution, and the 2 Buicks were running 1 and 2 through, at least through the first 6 laps. What happened with the constant flow fuel injection run, with the car running about 100 mile an hour, there was a lean spot there, and Pancho actually burned the piston on the caution laps, so he dropped out, and Scott Brayton dropped out a couple laps later for the same reason. So, talk about the thrill of victory and agony of defeat. That was it. So, okay, Buick's best chance of victory came in 1988 with Jim Crawford driving. He was running second, had better speeds than the leader with 6 laps to go when he stopped for a tire change. And unfortunately, when they stopped for tires late in the race, hot, and there are vehicle jacks that are mounted to the vehicle body that they raise the car with to change all 4 tires at one time. Unfortunately, the jacks sunk into the asphalt in the pits, which had been repaved that year, and it took them a whole lap to get the car freed, and so consequently our chance of victory evaporated. But to this day, if you watch in the pits, every team has sheets of steel that are in the pits. That is where the jacks go because of that event. Another interesting thing, in 1992, Roberto Guerrera qualified on the pole and managed to spin out during the parade lap. So he went from being sitting on the pole to being the first car out. So went from first to 33rd in 1 lap. So that was the last year of direct Buick involvement in the Indy 500. A couple of the teams continued to run them through '97 when the rules were changed, so that eliminated the boost brake. So that was the end of it. But we came close, but no cigar. But even though we never won at Indianapolis, the performance there, as well as in other racing series, did establish the V6 as the performance engine. After all, everybody likes a winner, and from the track to the customer experience, the V6 certainly became a winner. After all, approximately 19 million customers couldn't be wrong. Thank you. Questions that I can humble with? Yeah.
Where did the Turbo 6 emblem come from? How did that come about?
Well, that was we have been working with a company called Molly Designs, and he was a one-man show. He actually designed it. But it was intended to be a 6. It looked like it's tubular, so it represents turbocharging, but it became the symbol for all of the high-performance engines. You'd see them on the GNXs as well as everything. But that was it. It originally came through Special Products from a company called Molly Designs. Very, another highly gifted artist, but one of the most difficult guys to work with. Okay, but anything else? Yeah?
Ron, do you remember what year it was that Buick ran a 24-hour, 120 mile an hour for 24 hours with Buick? In the late 70s, I think.
1960, I think.
1960, yeah.
10,000 miles in 5,000 minutes.
Yeah, Daytona 500.
Average over 120 miles an hour.
Daytona.
Yeah, they had, the only thing they'd stop for was tires and driver's change, and they fueled the cars on the road. They had a fuel car set up, so they fueled it like they fueled jet engines. And they transferred fuel at race speeds into the car.
Down the back straightaway, come up a long mile turn, right in there, and you feel it, full fast.
I think it was 1960.
The guy behind that was the head of reliability, Bob Spinner.
Okay.
He's one of the more than that.
Okay.
How big of a team, how many people do you have in Special Products?
Well, in the engine side, we probably had, about 7? It was really a fairly small group. A lot of the work was done outside, so our job was really to coordinate that stuff. But still, as far as finally getting the designs on paper and released, it was all our responsibility. But we did most of it was coordination activity with a lot of outside builders and casting sources, you name it. But there were about 7 people involved in the engine program, and then there were other people involved in the show car part of it, doing a lot of the contacts for race teams and whatnot. There was a NASCAR contact, for example, that continued on and that kind of stuff. But the engine activity itself, there were about 7 people.
Buick had success in NASCAR into the early 90s, even with the new Regal car.
Yeah.
So did the rules change at one point to sort of...
No, it was just that dealing with NASCAR, we used to have an engine builder, I'll tell you a story about first. He was as much of a philosopher as he was an engine builder. And he said, Ron, so you got to understand, when you go racing with any of the sanctioning bodies, you're there to put on a show. Says equality of rules has nothing to do with it. You're there to put on a show. Don't ever forget that. So when it became our turn to still win, they'd like Bobby Allison was still continued to be very successful. He continued to run Buick, and there were a couple others. But it was a whole lot more equal at that point. It certainly wasn't a runaway, and we were not interested in spending a whole lot of money underwriting teams, and so some of the other people stepped up, and we kind of scaled the activity back, but we still did some of it. Yeah.
Is there a comment on how the Dark Buick cylinder came to be for the Chevrolet small block?
Well, that was aimed at like NASCAR.
But Bobby Allison, I think, he's become so much success with the V6, and he decided, why don't we put this head on the V8, and you guys actually went off and designed that and ran better.
Well, that was one of the things for, like in the true NASCAR series, you did what you had to because Chevrolet was doing it, and everybody else was doing it, so then we thought, okay, if that's what it takes to keep, because NASCAR was big enough that you couldn't afford not to be a player and still not get the Buick name out there. And a lot of that stuff, like a lot of the Stage 2 cylinder head activity and whatnot to get the flow rates and stuff, you know, some of those builders and, in the head porters, you know, they were real geniuses as far as cramming air through there. And so you talk to them and they tell you, well, why don't you do it this way? Well, no. So we would. So that's kind of how the whole thing operated, you know.
You had pictures of so many racing Buicks in all the series that I've never seen before. Any idea where any of those cars are today?
I would have no idea.
Many of them, I presume, were destroyed, or?
Well, I'm sure, you know, ultimately, a lot of that stuff gets to be about money, you know, and teams sell cars, and I'm sure there's, you know, somebody collecting that stuff, and fact is, I ran into Lee Brayton, Scott Brayton was killed in 1997, here a couple years ago, I'm not sure where it was, but I ran into his father, and he was actively putting a couple of V6s in the old Indy cars just for showpieces. And so there was still some activity there, but as far as what happens to the rest of the cars, I have no idea. Yeah.
Would you care to comment on why you never put stage 2 block and then made a production run of some small volume in like the Beard Grand National Regal, why you never did that?
Well, it's all money, you know, because it's all about having enough resources to do something. When by the time you got to put something in production with all the validation requirements and legal requirements, you know, it becomes a barrier too high to reach. So
Costs
it's
more money
just
to do that
strictly
than
money.
make the stuff.
Yeah. Okay.
Ron, you had a picture of a crankshaft early, and it looked like the main and rod journals actually had a groove in it.
That
Or
was
that just a covering?
no, that was just from the picture. We're really
Okay, there wasn't anything special you did to the
They
OD?
at some time
journals?
at one time, I think what is actually shown there, they were cleaning up flash from the forging, you know, and they kind of
Okay.
spun it around the grinder and
Okay.
knocked it off. And no, there wasn't anything intentional, it was just the way it came out, so. Okay.
Thank you very much.
Thank you.